taping. So given the function, first derivative, second derivative, I'm ready actually for this problem. I know x cannot be 1 and minus 1. Notice the derivative says x cannot be 1 and minus 1. Second derivative, x cannot be 1 and minus 1. So when I make my box here, this is the minus 1 here, and this is the plus 1. 1 and dne does not exist. Or negative 1 and dne. 1 and dne. So when x is minus 1, function does not exist, the derivative does not exist, the second derivative does not exist. The same thing for the 1. Now, the critical numbers. Let's begin with the first derivative. Find out where's the first derivative is equal to 0. That's the first derivative. The top will never be 0. None. Because if you set it equal to 0, negative 5 will never be 0. And x squared plus 1 will never be 0. Where is the first derivative and define? Plus or minus 1. So we knew that. So there is no additional cut right here. That's it. So we're going to take a test point in each segment, less than the minus 1. Negative 2. Between minus 1 and 1, 0. More than 1, the 2. And let's find the derivative. Now, here's the good news. Let's look at the derivative. Watch this. I don't even have to plug in numbers. The bottom is always what? Positive. This piece is always what? Positive times a negative? Negative. Negative over positive, that's what? Negative. So regardless what number I pick in, go ahead and waste your time. I guarantee you the answer is going to be negative. So I don't have to waste my time plugging numbers here. I know it's negative, decreasing. I know it's negative, decreasing. I know it's negative, decreasing. At 0, this is a negative 5 on the top. That's positive, still negative. It's always going to be negative. So no min, no max, it looks like it. It's always decreasing. Done with the first derivative. Now second derivative. Where's the second derivative is equal to 0? That's when you take the top of the fraction, set it equal to 0. Yep. You have 10x is equal to 0. You get x squared plus 3 is equal to 0. This will never happen, this piece here. This one, x equals to 0.
Oh, that is positive.
Which one? Can't be.
Negative
That's 1.
Times 1 is negative.
Yep.
Over negative.
There's a square. Yep, there's a square there. Second derivative does not exist where? X equals plus or minus to 1. So there's one more cut that's at 0 for the second derivative. One more cut. When x is 0 right here, the y value is actually 0. Yep. We plugged into the original problem right here. 5 times 0 is 0 over minus 1. That's 0 over anything is 0. So let's take a test point in each one of these segments and test the second derivative. Here's my second derivative, so I don't have to keep going back and forth. Let me pick like a negative 2 again. Between minus 1 and 0, negative 0.5. 0 and 1, how about a 0.5? More than the 1, how about a 2? What is the second derivative at negative 2? That's a negative here, right? This piece is negative. This piece is what? Positive. This piece is what? 4 minus 1, 3. Cube it, that's positive. Negative times positive over negative, that's a negative. Concave downward. Let's try the second derivative at negative 0.5. This is negative. That's positive. Negative 0.5 squared at 0.25 minus 1, negative 0.75 cube it, that's a negative number. Oh. That tells me it's concave which way? Upward, right? Now that looks like an inflection point, doesn't it? But it's not. Why? Because the function has a hole in it there. It's not connected. How about the 0.5? Well, the first piece will be positive. This will be what? Positive. This will be negative. That's a negative. That's an inflection point now. That's an inflection point. And what about after the 1, the 2? Let's plug it in. That's a positive. 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 Now let's answer, we'll graph it, then we'll answer some of the questions and see what we have. Between this box and the graph, I should have everything that I need to know. Maybe one question, I'm going to have to do some extra work on it. I know I have vertical asymptotes of minus 1 and 1. Big thick line, I don't have to cross them. Big thick line. X equals to 1, X equals negative 1. Okay, one thing I didn't do yet, where's my problem? Where does the function start from and where does the function end at? How do we find that? So, the start, we take the limit as x approaches negative infinity of the function. Notice that's bottom heavy. If it's bottom heavy, what's the answer? 0. What's the limit as x approaches infinity? Still bottom heavy, that's also a 0. So that tells me my function is going to start from 0, is going to end at 0. That's y equals to 0. It's going to start here. It's going to end there. That's your horizontal asymptotes. And there's one more question, then I can answer them. It says, what is the X-Intercept? How do you find the X-Intercept? set y equals to 0. So you take your function, the only way a fraction would be 0 of what? If the top is 0. So that's 0, comma 0. That's the intersection. So right here, that's the point. So the first question here, give me the intercepts, the x and by the way, it says the intercept. It didn't say x and y, it just says the intercept. To find the y-intercept, what do? You let x equals to 0. If you set x equals to 0, we have 0 over what? Negative 1. And what do you know? It happens to be the same point. Sometimes you have different values. Here, the x-intercept and the y-intercept happens to be the same. So my first question, what are the intercepts? 0, comma 0. 0, comma 0. Maxima. Relative maximum. Maximum point. Well, let's go back to my table. Is there any maximum point on that? No, it does not exist. How about minimum points? No, does not exist. How about inflection points? Yes, as 0, 0. So there's the first 4 questions. Find the equation of the asymptotes. Now the x asymptotes, and it doesn't say which one. Here's the vertical asymptotes. X equals to minus 1. X equals to 1. What about the horizontal asymptotes? Y equals to 0, the height. Y equals to 0. The vertical one, the smaller one, x equals minus 1. The larger one, x equals to 1. These are the next 3 questions. It's always x equals for vertical, y equals for horizontal. And now we're going to graph it and see what the graph looks like. Here's my box. That's all I need to graph it. Before the minus 1, we're going to start from here, and the function is decreasing and is concave down. Decreasing, concave down. The only way that could happen, if it's like this. Decreasing, concave down, starting from 0 and decreasing. After that, from the green line, that's this one, to the red line, that's this one. The function is decreasing, concave up. It's going to hit this point. Decreasing, concave up. From this point to this point, that's from here to there, right there. The function is decreasing, concave which way? Downward. And the last one is decreasing, concave upward, but you're going to level right here. Decreasing, concave upward, leveling at this line, and that should be your graph. If I went to my calculator and I graphed it, I'm sure I'll get that graph. I gotta move a little fast today, trying to finish everything to get you ready for the test. And try to cover some of chapter 5. Number 7. I lost the mouse. Where'd you go? Oh, here we go. F of x equals x cubed over x squared minus 81 on mine. I know x cannot be what? Positive or negative what? 9. So for this one, I should have vertical asymptotes of plus or minus 9. So my vertical asymptotes, right now, I know where they are. X equals negative 9, and the other one, x equals to 9. There's 2 questions I just answered. Find the equation of the asymptotes. We got this. Now, while I'm here, let's look at the horizontal asymptotes. Since the top is higher than the bottom, we have a slant asymptote. Let's find out the equation for the slant asymptote. That's the only time you'll have it, if the top is higher than the bottom, and usually with all these problems, 1 degree. So this is 1 degree higher than this, 1 power. So to find the slant asymptotes, we divide the top by the bottom. What's x cubed divided by x squared? X. What's x times x squared? X cubed minus, what's x times 81? 81x. Subtract the 2. And what do you have left? 81x. Can you divide 81x by x squared? No. That means f of x now can be written as x plus 81x over x squared minus 81. And there's your slant asymptote. Y equals to this one. Y equals to x. So that's another question. The slant asymptotes. Y equals to x. Couple of things here, just with what I know so far. If I was graphing this, this is what I know. Let's say this is the plus 9 somewhere here, and there's the negative 9 somewhere here. I got vertical asymptotes right here. X equals negative 9. X equals 9. These are my vertical asymptotes. I get a slant asymptote, y equals to x. This is y equals to x. Might be in trouble here space-wise. I don't have enough space here. Should make it a bit smaller. But we'll see what happens. So I'll leave this page handy for later. That's my slant asymptote. So let me make my table. I didn't find the derivative yet, but I can guarantee you, since the function is undefined at plus 9 minus 9, I'm just going to go and run a line through it, because I know the derivative, first and second derivative, will have the same thing. I don't have to look. It will be there. Okay. Let me take a test point. Before I do that, actually, I didn't even do the derivative. I forgot the derivative. I didn't do them yet. So let me take a nice clean sheet of paper, leave these 2 pages handy. What's the derivative of x? And again, go to my cheating friend here. I want the derivative of x to the third divided by parentheses x squared minus 81. The first derivative is x squared times x squared minus 243. They factor that for me. over x squared minus 81. Again, notice x cannot be plus or minus to 9. And what's the second derivative? You're going to use the quotient rule. And the second derivative, I clean it, 162x times x squared plus 243 over x squared minus 81 cubed. Using the quotient rule and simplifying your answer. X cannot be plus or minus 9 again. Now let me finish the boxes and let's look at the first derivative. Where is the first derivative undefined? The X-intercept, all the good stuff. So the first derivative is equal to 0 where? When the top of that's equal to 0, that means x squared has to be 0. Or x squared minus 243 has to be 0. This will be x equals to 0. And x is going to be the square root of that number. 243.
9 times the square root of 3.
Is it 9 times the square root of 3?
Yes.
Plus or minus. Approximately, just see what that number is.
15.59.
So approximately 15.9, you said?
Yeah. No, 15.6.
Yeah. Okay, it's somewhere around 15.6. So I'm going to leave the numbers the way they are. So negative 9, this somewhere here. Negative 9, the square root of 3. Now I got to find the y value for it. Boy, am I lucky. And 9, the square root of 3. And the other number is the 0. These are the three numbers. X equals to 0. X equals plus or minus. So now when you plug them in, when x is 0, the y value is 0. Plug them into the problem here. When you plug that number here, it's not going to be a pretty number, but if you have one of those graphing calculators, just plug it in, and it will give you the answer. Just put it in the exact mode. That's just the software I have here. I get a negative 27, the square root of 3 over 2. Is that what you got? And the other one, 27, the square root of 3 over 2. Some ugly numbers.
How does your calculator give you that?
You can put in the exact mode. You can put in the exact mode. So you type the problem there.
Yeah, but how do you do that with a cheap calculator?
Oh, I gotta
Because
buy.
it will not accept decimals.
I
I
get-
put the decimal all
yeah.
the way to fucking 9.
Oh,
And it
oh. Watch your language, Jordan.
It drove me crazy.
Yeah. They actually can go on the computer and just type in TI-84 free online graphing calculators.
I have the graphic calculator, but we can't do that in an exam. That's what I'm saying.
Oh, don't worry. I got you covered
Okay?
on the exam. I got you covered. But with these, you have to use exact values, yeah, because they're going to ask you for the exact value for these. The TI-83 might do it. Do you have an 83?
Oh, yeah. No, yeah, it will.
Yep.
This won't.
Oh, that one. Yeah, I want to say the 83 will do it.
Yeah.
Yep.
Oh, yeah, any
Yep.
graphing calculator will.
Yep.
Yeah.
Yeah, they have an online one for the homework. They have an online graphing calculator on the homework. I'm actually working, I can't tell you what I'm working on for the next test, but it's a surprise. I'm working on something. I can tell you that. I hope not, but I might surprise a lot of you. No, just like something you weren't expecting. Not a problem. I'm not talking about a problem, just the way I'm going to do it.
Rainbows?
Huh?
Cookies and rainbows?
Well, maybe. But I'm working on something because I want to speed up the process. So I'm working on something to speed up the process. Let's put it this way. Because I might have you just do the first half of it, bring you back to finish what I need to finish, instead of going home. So I got to squeeze something, try to get chapter 5 in, the stuff I want to cover. So now we're going to take test point in each one. But I got these crazy numbers. I'm actually lucky because I got one of those TI-89 that does everything, You really can't use it on the test. But once you finish with calculus 1, 2, and 3, we said you have to buy one of these. If you have it now, I don't have to teach you any of the stuff because you can just push them and it tells you what the answer. And you're going to see I'm going to say close your calculus. I'm trying to make sure the test does not have calculators on it. So I'm working, as I said, I'm working on something to put our calculators aside so it's fair and square for everyone.
Sounds like fun.
Yep.
There's going to be a portion of the test where
Possibly. You might be able to use the little one there, but that's it. Yep. I'll have a box of the little calculators for like $10 a piece. I have a whole box of them. You can use those.
25.
If you went to East Coast Market, I think $8, $3, you can get something scientific.
Nice.
Yep. So I said, make sure you know the stuff. If you know the stuff, you'll be just fine. You'll be going, oh, this is the easiest test we had. If you don't know the stuff, you're going to be like, oh my goodness. So if you've been counting on doing the stuff, some external sources, you're in for a surprise. Okay, let's take a test point in each segment. I asked George, what's that number? He said negative 16 point, what was it? This one? So there's a cut here. We have a lot of cuts now. Oh boy. This is roughly negative, what was it, George? 16.5? 15.6? 9?
15.6.
So I'm going to use negative 16. Between negative 15 and change and this, I'll use a negative 10. Negative 9 and 0, about a 1. Negative 1. How about 0, 9? That's a 1. 9 and 15.6, how about a 10? 10 is a good number. How about a 16 or 20? 20 is a good number too, because decimal number, anything with zeros in them, always good numbers. And now you're going to find the derivative. So where's my derivative?
Are you going to change negative 16 to negative 20?
I left it because I don't want you to think it's always symmetric. It has to be the same value. I thought about that, but I don't want people to think this number has to match this and this has to match that. It could be any number. So that's why I left it actually. But it makes sense because it'll be quicker. But I don't want you to think it's always they have to be matching numbers. So now I'm going to go to the derivative. Here's the good news for the derivative. I know the first piece is always what? Positive. So when you say on the test, we don't have enough time. No, because you're not doing it right, like cheating. Cheating doesn't mean look at the person next to you. Look at this problem. You know this one is what? Always a plus, right? When you square a number? This one? What about that one? X squared minus 81 squared. That's always a plus. So all you have to do, really, all you got to do, take that test point, square it, subtract 243 from it. If it's negative, you know that's negative. If it's positive, the whole thing is positive. Because as far as we know, these two are positive. So the last one is going to determine what's going to happen. So here's f prime of negative 16. If I use the 20 now, I know that's 400. See? So negative 16, square that number. 256. What's 256 minus 243? Positive or negative? Positive. So this is a plus. Let's try the 10. Again, the first piece is positive, the last one is positive. Negative 10. Square it. 100 minus 243. Negative. That's a negative. What do we have? Max point here. Up, down. Take the minus 1, plug it in. Negative. Decreasing. Take the 1, plug it in into the derivative. Positive, negative, positive. That's negative. Decreasing. This point is neither. Take the 10, plug it in. Positive, positive. Now here, 10 squared is 100 minus 243, that's a negative. That's a negative. Some of you are going to waste your time trying to find what that answer is. I'm not going to waste my time. And the last one I know is going to be positive. That's my midpoint. That's the first box. Now I got to do the second derivative. Let me write the second derivative down so I can use a whole sheet for it. I already have it done. Three, yeah. We know it does not equal to plus or minus 9. I already know that. I put them in. X equals negative 9. That's vertical asymptote. X equals negative 9 vertical asymptote. We did that early. When is the second derivative going to be 0? This will never be 0. So the only time will be 0 when 162x equals to 0. X equals to 0. That's good for us because that's only one cut, and the good news, we know what the y value already. We did that. Right there. In case you can't see it, right there. That was one of the numbers. So I don't have to calculate anymore. Let me pick a value less than minus 9. About negative 10 is good. Between minus 9 and 0, negative 1. 0, 9, how about a 1? More than 9, how about a 10? And let's plug them into the second derivative. Now let's look at the second derivative. Now let's look at this one here is always what? Positive. That piece always positive. This one could be anything. So let's look at it for the negative 10 first. For the negative 10, this piece is going to be negative. And the bottom, when you take a minus 10 squared, that's 100. 100 minus 81, positive cubit, that's positive. That's a negative. Concave down. What's the second derivative at minus 1? Negative, positive. In the bottom, minus 1 squared is 1. 1 minus 83 is negative cubit. That's a negative. That's a positive. Again, first glance at this, it looks like an inflection point. It's not. There's a hole there. Let's take the 1. Positive, positive over negative. That's a negative. If it's negative, concave down. What do you know? What do we have here? Inflection point. We change concavity. And when we take the 10, that's a plus. That's concave upward. Almost done. I found the slant asymptotes. I found the vertical asymptote. There is no horizontal. We have a slant. The only thing I did not find is the x and the y-intercept because they ask you for them. So if I can finish that, the x and the y-intercept, I'll be in good shape. Then I can graph it. So let's find the x and the y-intercept. There's f of x again. The x-intercept, what do? Let y equals 0. So 0 equals x cubed over x squared minus 81. X will have to be 0. That's the only way. The y-intercept, you let x be 0. Y equals 0 over negative 81, which is 0, happens to be the same point. It's not always the case, it's just both examples happen to be that. I'm done with all of these, now I just got to graph it. This should be enough to graph it. This is the 0, 0. Let's look at this piece. We have the vertical asymptote, we have the slant asymptote, we have the x-intercept. We just answered the first 4 questions. It says, okay, where's the min and the max? There's the max, there's the min. Where's the inflection point? There's the inflection point. We answer the next 3 questions. Now the last thing is graph it. So let's look at it. Before I get to the red line. Okay, where's the negative 9 squared? That's almost negative 15. Somewhere here, and the y value is negative, down here. That's the max point, like this. Extend this line. As I said, I might be out of space here. It says the function is increasing. Let me extend both of these lines. It's coming from here. It's increasing till it hits that point, then start to decrease. That's what this one says. Increase concave down. It hits that point, decrease concave down. I got that piece. I'm definitely going to need some space there. There's no way I have enough space to graph it there. Now, from the red line, which is that red line, let's go to the black line. That's this line. From here to there, my function is decreasing concave upward. Decreasing concave upward. It hits that point, then it's decreasing concave down. And the last one after the red line, there's another point somewhere here. It's a maximum value. I mean min value, I'm sorry, not max, min. Min value. The function is decreasing, coming to it. It hits that point, then increases. It's going to go asymptote with that. So if you can see the graph, that's what the graph will look like. It's decreasing, coming from up there till it hits that point. Then start to increase concave upwards, going to level with this line. And do I have a picture that looks like this? Yes. And D is the one. A lot of work just to get the graph. I don't think I'll have time to do all of them. I only did 2. And I got 3 more. Let me just see if anything's similar. Eliminate that. 8 is okay. Oh, the other 12. Let me see what 12 is. Oh, no, everyone is different. Let me see how I'm looking on time. I'll grab the next one. If I run short on time, I'll leave them.
I can try to make the next one simple for you. The only question I have regarding it is why we're using the intercepts from both the function of x and then f prime of x for whatever reason. It just seems strange.
Let me look at it. I think I have time for it, George. Let me look at it. Because that has a V shape, I can tell just by looking at the picture.
Yeah.
Because the derivative is going to be undefined at 0. So this is number what? 8? So f of x equals 12x to the 2/3 minus 8x. The good news here, there's no value that's the function undefined. Because that's the cube root of x squared. The cube root of a negative number is okay.
Yeah.
You can take the cube root of a negative number, a cube root of a positive number, a cube root of 0. So the domain's all real numbers. So you're good there. The derivative of that we can do without calculator. 12 times 2/3, which would be what? 8? X to the negative 1/3 minus the 8. Which means 8 over the cube root of x minus the 8. So now the derivative x cannot be what? 0. That's where your derivative is undefined. So the derivative of x is equal to 0 where? 8 over the cube root of x minus 8 is equal to 0. Solve that. 8 over the cube root of x equals to 8, or 8 over 1. That means the cube root of x has to be 1. X will have to be what? 1.
Yeah.
And the derivative is undefined. We already said that. X equals to 0.
So that's your critical value there.
These are my 2 critical values. The derivative is undefined here. That means I have a V shape, either up like this or like this.
Yeah.
That's what that tells me at that point. The derivative, because the function is defined there. If it was undefined, it would be a vertical asymptote. There's no connection. It says the function is continuous there. There's no gaps in it. But the derivative does not exist. Well, if the derivative does not exist, it's a V shape. So I know I have a V shape right there. So maybe I remind myself when I get to it. Here's my box. F prime, F double prime. I get 2 numbers, the 0 and the 1. And to remind myself, maybe I'll put a V here or something just to remind me. Either upside down V or it's going to be one of those shapes at 0. And the 1, let's see. And now we're going to take a test point in each segment less than 0. That'll be, I don't know, negative 1. Between 0 and 1, I'll use a half or 0.5. More than a 1, I'll use an 8. 8. I should use a negative 8 here.
There's another segment though. There
Four.
are 2 X-intercepts.
Oh, I'm going to get to that, yep.
Oh,
Yep.
okay.
I always say them till the end usually. the X-intercept. But I can do them there.
So that's right, yeah.
Yep. So notice I'm taking minus 8. So why'd you pick minus 8? What is the cube root of minus 8?
2.
Minus 2, right? So here we go. New sheet. So this is f prime of x. Well, I'll leave the paper. I might need it. So what is the derivative at 8? It's 8 over what? This will be a negative 2 minus 8. That's negative, negative. I don't care. It's negative, right? I don't care about the value. That's what I meant. Decreasing. What's the derivative at 0.5? I should have said, I was thinking 0.125 because that'll be a half. But 0.5. That's a positive. You can test it. That's a min. Well, if it's a min, guess what? It's going to be a v. Because if it's upside down v, it's what? It's a max. That tells me that's a min now. I forgot to find the value when x is 0. I think it's 0, right? Plug into the original function. When it's 1, what do we have? 12 minus 3, which is what, a 4? I'm going back to the original problem. Now the derivative, this outside the box. So we go back to f of x. I just forgot about them. And what's f prime of 8? That'll be a 2. 8 divided by 2, that's 4. 4 minus 8, which is also a negative. And that's what? Decreasing, that point is what? Max? That's the first derivative. Now I got to find the second derivative. Let me save some paper, continue with this. What's the second derivative x? This is the first derivative. Take the derivative of this. Negative 8 over 3. X to the power of negative 4/3. Where is the second derivative equal to 0? None? Where is the second derivative undefined? At 0. I already have the 0 as a point, just extend the line. Take a test point. Less than 0, I'll use a negative 1, just to show it doesn't matter. More than 0, I'll use a 1. Doesn't really matter what I use for numbers. I know what the answer. When you put a number and raise it to the 4th power, that's an even power. If that number positive or negative, when you raise it to the 4th power, that's what?
Positive.
Positive. The cube root of that, positive. Times 3, that's positive. So the bottom is always positive, regardless what you use for a number. The top is always negative. What's a negative over positive? Negative. So the second derivative, always negative. Always concave down. And the only thing I didn't find, and George brought to my attention, says you didn't find the x and the y-intercept. So let's find the x and the y-intercept. Once I have them, I can graph my function. So we have a min, we have a max, we found them. Inflection point, do we have inflection point? right here.
That's
I
undefined.
thought
This undefined, the functions continue there. Let's see.
No.
Nope, the function is defined for all of them.
I thought the concavity had to change for
Inflection point.
And prime.
I have a V shape, so it can't really be. It's not going to change concavity there. Let's see. It's going to be a V shape. It's going to be like this. That won't be. Yep. That's not going to. That won't be an inflection point. That's a V shape here. The function is defined there, but that's a V shape. That's why it's not an inflection point. Anything here? Nope, we don't change it. So no. Intercept, X and Y intercept. Asymptotes, by the way. Nothing. Asymptotes when you have fractions. You don't have a fraction. The original problem didn't have fractions. The vertical asymptotes, that's when the bottom is 0. We don't have that. So let's find the X and the Y intercept. So I'll put on this page X intercept, you let Y be 0. And what was the problem? 12x to the 2/3 minus 8x. You can factor out 4x out. If I take a 4x out, what's left here? 3x to what? Negative 1/3 minus the 2. What's x times x to the minus 1/3? X to the 2/3. So you set that equal to 0. That says, oh, wait a minute. You're multiplying two things. Your answer is 0. One of them has to be 0. This one, x equals to 0. That one, let's see. Solve it. 3x to the negative 1/3 is equal to 2. That means 3 over the cube root of x is equal to 2. 2 over 1, cross multiply. Cube root of x equals what? 3 over 2. Try to cut corner. Now it's killing me. I have no space. And to get that number, to solve for x, what do? You raise the whole thing to what power? How about 3? It's the 1/3 now. To make it a 1, you cube it. That will be 27 over 4. So 8, not 4, cube. 2 cube is 8, right? So it's 0, 0, that's 1 point, that's x-intercept, and 27 over 8 and comma 0 is the other one. To get rid of the cube root, you cube both sides. So we answered the first 1, 2, 3, 4, 5 questions. 6 questions. It says, where is the intercept? Right here. Where is the minimum? Right here, 0, 0. Where is the maximum? Right here, 1 and 4. Inflection point, none, does not exist because that's a V shape. Find the equation of asymptotes. There is no asymptotes. So the last one, just graph it. Here we go. Let me graph it. We have 2.00 and 1 and 4. One and 4 is a max, 0, 0 is a min, but that's a V shape. Before the 0, 0, the function is decreasing, concave down. Decreasing, concave down. That's the only way decreasing, concave down. What happens after that point? Increasing, concave up. It's a V shape. That's why this is not an inflection point. And what happens after the 1, 4? Decreasing, concave down.
Wasn't that when I asked you where it starts and stops?
We don't have it because you don't have a fraction.
Right.
And if we look at the picture, we should have something similar to that. Do we have anything similar to it? Question, which one's 8?
Yeah, there's
Is there one? I'm moving to my, where is it?
probably B.
Oh. It's actually E. Yeah. On my case, because they shuffle them around. You know, they don't leave them the same. So that's what happened there. Ugh. Who picks these problems? And then you go, well, you don't do them. I do them because I come every class. I do almost all of them. Arc sine, yowza, x minus 9 over 9 squared. This is u. When you're doing the arc sine, this is really u. Now, if you remember the derivative of arc sine of u, again, hopefully you memorize them by now because you need to memorize them. U sub prime over what? Is it a square root? 1 minus u squared. So the derivative of this, there's a 6 sitting in the front. So there's the 6. What's the derivative of this one? If you don't like the way that's written here, rewrite that. So u actually, let me just do this. You can write it like this. What's the derivative of that? This times this. X minus 9 to the power of 1 times the derivative what's on the inside of that, which is a 1. So now you plug them in. G sub prime of x, that's the first derivative. There's the 6. U sub prime, 1/9 over the square root of 1 minus, that's 2 over 9 here, right? I put the wrong one. I'm seeing things now. And that's a 1 here. 1 minus this one squared. 1 over 9 x minus 9 squared. I gotta square the whole thing.
1 over 9, it should be 1 over 81, right?
Yeah, I'm leaving it squared.
No, up there. U equals 1 over 81, right? Yes.
1 u equals, where's u?
Because you're,
Oh, that's the, oh yeah, that's inside. Is that inside? Yep, it is inside that. That should be 81. Very good, good eyes. Because this actually was the whole thing squared, not just the top. So this will be an 81. Because you got to square the 9. Ew. 6 times 12, which is what? 6, I mean, 6, I just gave you the answer. 6 times 2 is 12 over 81. I gotta do 1 over 181 squared. How about we factor 1 over 81 out here? If I factor that, I need to have 81. Well, I'll show it to you what I'm doing actually. Maybe you need to see it to see what I'm trying to do. I'll take an extra step. I was about to put in one answer. 1 over 81 squared. I decided to factor that. What's left here? Well, I don't have that. That means I better make this one 81 squared. So when you distribute that, what's 1 over 81 squared times 81 squared? That's a 1. That gives you that piece. Minus, this will be x minus 9 to the 4th power. To take care of this, because I factor 1 over 81 squared out of both of these. Now the reason I did that, because that'll give me 1 over 81 outside. That was my intention. I can factor the 81. Oh, that's a over 81. And now the 81 will cancel each other out because they're on the top and the bottom. Oh, 81 will cancel. I just said they'll cancel each other out. And that's the first derivative. Well, if you think I'm going to do the second derivative, you're nuts. But we're going to find out where the first derivative is 0, where the second derivative is 0. Ooh. Okay. Which collapse all. That means I gotta take the second derivative of it. And I don't want to do the second derivative. Now that question is gone. I just took it out. That is not doable, just going to take like the whole night. Just to finish this derivative of this, now I got to go through that.
So that question's gone altogether?
I took it out of the test completely. But if your heart is broken, George, you can go back and do it.
I don't know.
And you know what? 12 for that reason too.
That was
The next one.
13? You mean 13?
Yeah, there was. Now it became a 12. Now it's gone. Yeah.
I only have 2 left.
So the last two are gone. Just because they're time consuming. I mean, they're not. We'll be here till midnight. I'll stop with the video.